Hello, my lovely viewers, and welcome to today's edition of Chemistry on Fauzan Harun channel. And I hope wherever you are doing great, and you had fun the last time we met on our first chemistry lesson, which is the relative atomic mass. And today we are going to treat a different topic altogether. Relative molecular mass. Relative molecular mass is going to be our topic for today. Relative molecular mass is going to be our topic for today. Please, if this is your first time of joining me on the show, please do well to touch the subscribe button, hit the notification pad, and then give it a thumbs up if you enjoy it at the end of the lesson. Share the program for so many students to also benefit. Thank you very much. Relative molecular mass. Just as we indicated the last time, relative molecular mass also takes the same manner of definition, but with slight difference as compared to the relative atomic mass. And so very soon you are going to get the difference. In terms of relative molecular mass, anyway, before I proceed, the last time I treated relative atomic mass, the last example that I was given, I gave an example of atomic mass unit. Those of you who watch the show, atomic mass unit of magnesium, I think. Let me see. Yeah, atomic mass unit of magnesium to be 24 mu. And then the atomic mass unit of magnesium to be 24 mu. So, atomic mass unit magnesium is equals to 24 mu. And the relative atomic mass of magnesium obviously is 24, but in my writing I wrote 12, and so that this is the correction. As you know, I know you know, but I'm just emphasizing that it's not 12. It was a slip of the marker that I wrote 12, but it wasn't 12. So that was the correction I want to make. So this is it, so that you don't misunderstand and say I've give certain explanation, I've change certain things. So this is the reality. This is the correction for the last example I gave. So let's clean it and proceed. Though I know most of you appreciate the beauty of it, you do understand. But it's good to clarify. Okay. Before you go and learn something which you are not supposed to learn. Okay. So we are still proceeding. We are going to when we talk of relative molecular mass of an element or compound, it is the average mass of one molecule of a substance. The average mass of one molecule of a substance divided by 1/12 the mass of one atom of carbon 12. So you can see that it is almost with a slight difference on top here. The relative atomic mass, average mass of one atom of a substance of an element, you see. And this one is average mass of one molecule of a substance or compound over 1/12 the mass of one atom of carbon 12. So this is the definition for relative molecular mass, for that matter. Relative molecular mass. So when you say relative molecular mass of NH3. NH3 is ammonia. Those of you who don't know, ammonia. I know all chemistry students know ammonia is 17. When we say the relative molecular mass of ammonia is 17, it means the molecule of ammonia or chemical compound ammonia is 17 times as heavy as one atom of carbon 12. So it is 17 times as heavy when you compare as one atom of carbon 12. So just as I said the last time, it implies 17 times as heavy as 17 times as heavy as 1/12 the mass of one atom of carbon 12. Sorry, not 17 times as heavy as the mass of one atom of carbon 12. No, 17 times as heavy as 1/12. 17 times as heavy as 1/12 the mass of one atom of carbon 12. So a scenario is just like this. So ammonia, Mr. Relative Molecular Ammonia equals 17 times 1/12 mass of one atom carbon 12. You can see it's 17 over 1. So over 1. So when you turn the comparison around, so when you have 2 over 1, you say it's 2 times as that of 1. So twice 1 as 1. So this is what it implies. We will be doing some calculations later to understand what I mean by the relative molecular mass, how to calculate it. So substances which exist as ions, substances which exist as ions, their molecular masses are referred to as formula masses. They are referred to as formula masses. Ions do have theirs, which is formula masses. Relative atomic masses are used to calculate relative molecular masses. So relative atomic masses is used to calculate relative molecular masses. So you see that so in this case, before you calculate the relative molecular mass, you will need the relative atomic mass of individual atoms in the molecule or compound you intend to calculate its relative molecular mass. And also relative molecular mass also has no unit. Of course, just like the last time I proved in the first lesson, if you've not watched it, you have to go and watch that video, please. I don't want to go back again. You have to go and watch the video. I prove it. The relative atomic mass has no unit, and this one to the same time. You can see there is fraction, so the numerator over denominator, and the mass will cancel it out, changing, and then 1/12 times 12 will also exit, just like I did. So I don't want to repeat because I don't have time to repeat it. I have time for other things to do. So let's look at an example, like in calculate relative molecular mass of ammonia, NH3. We take individual atoms, and here is 14 nitrogen plus 3 times 1. We have 3 hydrogen atoms there. So in effect, this is 14 plus 3, which is equals to 17. So that's why we said here relative molecular mass of ammonia is 17. So this is how the 17 was arrived at. So that is how we arrived at the 17. I will be calculating a little bit of examples before we proceed to our next topic, if time permits us. So let me give you some few seconds to go through because I'm going to clean it. As I always say, if you don't understand anything, please repeat or reverse the video to understand it well. So let me clean this part to proceed with my next calculation. I want to calculate some more examples so that we understand what relative molecular mass, how relative molecular mass is calculated. So if this is your first time of joining the channel, please do what, subscribe to the channel. So we are going to do some examples, to do some calculations. So we are to calculate the relative molecular masses of question. Calculate the MR of the following compounds or substances. We have H2O, II, we have H2SO4, SO4, III, we have Na2CO3, Na2CO3, then we have CO2, then we have NO2, and then we have C6H12O6, H12O6. So we are going to try these examples on relative molecular masses. So I think our viewers have started seeing the difference between relative atomic masses and relative molecular masses. So we are doing the first one and see H2O solutions. MR, relative molecular mass of water, H2O, is equal to have 2 times 1 hydrogen. Hydrogen is 1. And then let's get the parameters right. Relative atomic masses of the elements. We have H is equals to 1, and then O is equals to 16, and then S is equals to 32, and then Na is equals to 23, and then C is equals to 12, and then N is equals to 14. So we are using that to calculate the relative molecular masses. Remember, we said the relative atomic masses are used to calculate the relative molecular masses. So this is what you have started observing. So, okay, so we take this one, 2 times 1 plus 16, because the oxygen here is 1, so 1 times 16 is 16. 2 times 1 is 2 plus 16 is equals to 18. So relative molecular mass of water is 18. Relative molecular mass of water is 18. The first one. So I hope viewers are getting it. The second one, II. MR, that's relative molecular mass of H2SO4, is equals to the 2 hydrogen is twice plus sulfur 32 plus 4 times 16. Remember, oxygen is 16, so 4 times 16. So we have the answer, I think, is 98. 98. You can use your calculator to confirm or deny it. It's 98. using your calculators is 98. Okay, so let's go to the next one. For Na2CO3, we have 2 times 23, that's the sodium oxide, plus 12 plus 3 times 16 equals to, so I think you get 106. 106. So this for the 1, 2, 3, and we'll do the fourth one, and then I will leave the other two as assignment for the viewers. Before I pause for this video and see if then the next topic we're going to proceed will be on mole. So the last one, which is the CO2, I then the fourth one, CO2, the MR for CO2 is equals to plus 16. So that one is 44, I think. Yeah, 44. So far, this is how to calculate for relative molecular masses of these substances or chemical compounds. So this is how to calculate for them. I hope we've understood it, and then I will leave the rest, the 2-vin, which is the NO2, nitrogen 4 oxide, and then the C6H12O6 as an assignment for the viewers to try and give the answers in the comment box. So I think without much ado, please, if this is your first time, do subscribe to the channel and share the program for many students to also benefit. Thank you very much for joining me on today's show. God richly bless you, and hope to meet you in the next subtopic. Cheers. Bye-bye.